Welcome back. Now we are actually going to go on a new fresh topic which we refer to as what? Probability. The concept of probability. Now, when we are talking about the word probability, what do we mean? We are actually saying that a guesswork, so to say, that we are predicting based on past occurrence, what we actually witnessed before. We are talking about, we are planning to see what we're going to get out of it as a what? As a topic. That is, and the skill to go about this topic is what we actually want to look into. If I'm considering the fact that you are about to watch a match, you understand? The frequent football match that you've been watching, and then you can base on the past history that a particular team has been winning for a specific number of times. Maybe in a team that involved Nigeria and Ghana, and you find out that Nigeria has won 10 times, and out of 15 times, Nigeria has won 10 times, and Ghana only won 5. And then in the next match, we're actually trying to predict that what is the possibility of Nigeria winning the next match. What is the probability that Ghana will defeat Nigeria in the next match? So based on this, you can make use of this concept to bring up your own deduction to tell the fans or to actually make a vote that Nigeria or other team will actually win. So don't let us digress from the academic part of it and let's see it. Now, when you're talking about probability, so there are some certain things we need to know. We need to understand what we refer to as what? Event. So we're going to find the probability of an event occurring. So, and then we're going to look at some certain things like E, which we're going to denote as E, which stands for what? Which stands for possible outcome. And then we're going to use the word S to denote what we call as a total outcome. Now, what do we mean by possible outcome? The possible outcome is that what has been occurring before, what we've been seeing that is happening in order to predict the future occurrence. That is what we mean by what? Possible outcome. And the total outcome is the total number that has occurred, whether it is good or bad or fair. That is what we actually say. So let's consider this a very simple example before we proceed. An example, we said Nigeria and Ghana are played football match 5 times, and Nigeria had won 3 times. So what is the probability that Ghana will win the next match? Now I want to see whether Ghana has a possibility of winning the next match. So in order to consider this, the first thing you have to know is you have to know the total outcome. So what is the total outcome that we have here? The total outcome is what? Is 5, because Nigeria and Ghana are played 5 times. So the total outcome here is what? The number of total outcome is what? Is 5. You understand? The possible outcome for Nigeria is what? For Nigeria is what? Is 3. The possible outcome for Ghana is what? Is 2. Based on this. No, if you notice, you find out that Ghana is not specified here, but if you find out that if Nigeria had won 3 times, definitely, and it is not stated that there was draw at any point in time, that means that Ghana won twice. So out of what? 5. So what is the probability that Ghana will win the next match? Which is the probability of Ghana winning the next match is 2 out of 5, because they actually hold 2 to themselves, so it is 2 out of 5. So the probability of the event occurring, which is the event of what? Winning. The event of winning occurring is what? 2 out of 5. So the probability for Ghana to win is what? 2 out of 5. Now, for Nigeria to win, the probability for Nigeria to win is also what? Is 3 out of 5.
Now, that is Nigeria winning. The probability of Nigeria winning is what? 3 out of 5. Another example. If we have, it's a Nigeria and Tunisia had involved in tennis competition 10 times. Won 6 times. What is the probability of 1. Nigeria won the next match? Another one, what is the probability of Tunisia lost the next match? 3, probability of draw the next match. Now, what is the first one is what's the probability of winning the next match. Second one, of Tunisia losing the next match, and third one, draw the next match. Now, the essence of probability is to be conversant with your environment. You know, you have to be very familiar with every event in order to predict the possibility outcome of that particular event. Now, to solve this, we said that the total possible outcome is what? Is total outcome, rather, the total outcome is 10 because they played 10 times. The total possible outcome for Nigeria is 6 times. That means for Tunisia, it is what? It is 4 times. The probability that Nigeria will win the next match is what? Is 6 out of 10. So if you divide this, you can simplify this by dividing by
2 and by 2. So that means we
have our answer to be what? 3 over 5. So that is the probability that Nigeria will win the next match. Now, the probability of Tunisia losing. Now, there are 2 ways to this. Now, you can decide to find the way. Now, that's like what we find here. Now, this is the probability of Nigeria winning. The other side of this will be the probability of Tunisia losing. Or you can decide to find out the probability of Tunisia winning and then find the opposite of it. That means the Tunisia will be what? Will be losing. Now, what I'm saying in essence is that, now, to find this is to find the first one. So find the second one, probability of Tunisia wins is what? Is 4 out of 10. And that means that it is what? It is 2 over 5, right? Now, if they are not winning, that means they are what? Losing. So that means the probability of losing will be what? It will be 1 minus 2 over what? 5. Opposite of this. Now, note that the maximum value you can get in a probability is 1, and the minimum value you can get in a probability is what? 0. So that means that 0 is less and equal to probability, and probability is 2 to 0. So that is that about that. Now, what we are saying here is that the probability, the maximum value you can get in a probability must not exceed 1. The maximum must be 1, and the minimum you can get is what? Is 0. So we say 0 is greater than or equals to probability of is less and equals to 1. So now, going back to this question, we said the probability of Tunisia winning is what? 4 out of 10. So we are actually looking for the probability of losing the match. that means it's opposite of winning the match. So since it's opposite of winning the match, and we said that the maximum value is 1, therefore we need to less this from the maximum of winning, then we'll get the value of losing the match. So if you minus this, you can convert this 1 to any fraction that we have based on the denominator that we have here. So since we have denominator to be 5, so you can decide to have 5 over 5 because 5 over 5 is still the same thing as what? 1. Let's assume that we have 20 here. So that means we can decide to change this 1 to what? 20 over 20, which is the same thing as 1. So because it's 5, because it is 5, so let's leave it as 5 over 5 minus 2 over 5. So that will give us what? 3 over 5. So the probability of Tunisia losing this particular tennis match is what? 3 over 5. Now, the last question. What is the probability of drawing the next match? Now, if you look at the tennis game in the first place, do we actually draw? That is the first thing you should ask yourself. In the question, there's no indication that there is a draw. But now let's now say, okay, maybe the writer of the question omitted to the finding that there is probably maybe they might have drawn one time or the other. But we must ask ourselves, is there any possibility of drawing a tennis match? The possibility is it is not possible. That is, no, you can never draw a tennis match. Therefore, the probability of drawing the next match is what? Is 0. So it's not possible for us to draw in a tennis match. Therefore, no possibility of drawing in the next match. So since there's no possibility, so we refer to 0. I hope that is clear. Action. Now, looking at the next episode on this the word probability, we're going to look at what we refer to as mutual exclusive event and independent event. Now these are two different entities that we're going to look at now. First, we'll look at what we refer to as what? Mutual exclusive event. What do we mean by mutual exclusive event? It's a simple word, but it's a simple way to approach but the mighty word. But don't let us mind the mighty, let's consider the real action taken. Now, when you are considering the word mutual exclusive, what that simply means is that the occurrence of one depends on of the other. They are like brothers and sisters, husbands and wives. So the following of this is very, they work hand in hand. It is A plus B. It is when we are considering A or B. This is in an event where we talk about or the word either. This is when we consider the two of them, when we are considering what? Mutual exclusive event. That's when we are talking about or and either, where we can refer to as what? A positive joining A, probability of A and probability of B. When we are considering the event, that what is the probability of A or B occurring? So let's see an example of that. A bag contains 10 balls that differ only in color. That differ only in color. 4 are blue and 6 are red. 2 balls are picked. 2 balls are picked. One after the other with replacements. What is the probability that the first is blue. The first is blue or red. Now, we are considering that we are picking a value. We are picking a ball. We are picking 2 balls. Now, after picking these two balls, one after the other ball, we are replacing. But we are not considering more questions than this. We just want to simplify the question first before we go into more complex questions under this. So what is the probability we pick a blue ball? That is just the simple question out of all this story. What is the probability of picking a blue ball or a red ball? So now if you remember, we talked about total outcome. What is the total outcome here? The total outcome is what? Is 10. So 10 balls is the total outcome. Now, what is the probability of picking a blue ball? The probability of picking a blue ball is what? Is 4. Blue ball is what? Is 4. And the probability of picking a red ball is what? Is 6. Now, we're now saying what is the probability of picking a blue ball or a red ball? So the probability of picking a blue ball is 4 out of what? Out of 10. And the probability of picking a red ball, it is what? 6 out of what? Out of 10. But the means something. It's now talking about what?
Or, and I said that when you're talking about or, whenever you hear or either, you should join it with what? With what? Addition.
So what that means that you're going to add this, you're going to add the red ball and the blue ball together to get your value. So it's going to be 4 out of 10, which is for blue, and 6 out of 10, which is for what? Which is for red. Then if you now add this together, we get what? 10 out of 10, which is what? The probability of picking a first blue ball or red ball is 1. What does that mean? This particular getting one, that when you have a basket full of 10 balls, which we have only 2 colors, which are red or blue, then the probability of picking blue is 1, because it's either you pick blue or you pick red. There's no other color you can pick except the 2 of them. You can't see black. You can't pick out black. So the probability of picking blue or red, because there's only 2 groups of balls there. It's blue and red. So it's either you pick the blue or you pick the red. And whenever you just lay your hand and pick a ball, you will surely pick a ball which can be red or blue. So definitely the probability of picking any of these two is certain. That means that is why it is what? It is 1. It is certain that you must pick either a red ball or a blue ball whenever you put your hand inside the ball. That is why it is what? It is 1. So let's say extend the question. What we are saying here is that they say the question is what? What is the probability that you pick blue or red? Now, the probability of picking blue is what? 4 out of 10, because the total number is what? 10. So we have what? 6. We have 4 out of 10.
Now the probability of picking red as well, it is also what? 6 out of, because there are 6
balls, 6 out of 10. So we have 6 out of 10. So I told you that whenever you see or in a probability question, it is indicated with what? With a positive sign. So that means positive sign is joining the blue or the red. Now, for us to now do this, then the next thing is now what? We need to add this up. Then the next thing we need to do is what? To find the LCM of these two values. Now, because these values are the same, the denominator here are the same, then we can easily assume that our LCM is what? 10. But let's now assume that we've changed. Okay, maybe we reduce one of them. Let's assume that we've divided this, we've simplified it to 5. You know, this is now going to be 2 over 5, and the denominator, we have to find the LCM of 5 and 10. And how I believe that we all remember how to find the LCM. But let's take a little fresh memory on that. We find the LCM. What is the value that we can find here, which is what? If you say 5 and what? 10. So what is the smallest value we can use to divide this? 2 can go. So 2 here, 2 cannot, so we leave it as it is. Then we write what here? We divide this by 2, because 2 can divide this without remaining. So it will be what? It will be 5. So 5 in this part will be what? 1, and 5 here is also 1. So multiplication of these two will give us what? 10. And that will be our what? Our LCM. But be that as it may, it is already in what? In 10. So since they are of the same value, we can easily pick our what? Our LCM to be 10.
Then how many 10 can we see in 10? Is 1. So we have what? 1. So 1 times 4 is what? 4.
So 10 divided by 10 is what? Is 1. 1 times 6 is what? Is 6. So we have that. Then we have what? 10 out of 10. So 10 out of 10, if you divide 10 by 10 using any means, then you must get 1. And then when you are, the reason why we are getting 1 as it were is to the fact that the certainty of getting a ball inside a bowl that contains only red and blue is just certain, because there's no way you can see another ball inside the bowl which is going to be other than red or blue, because we have only red and blue. So it is certain that whenever you put your hand inside the bowl, you will surely pick a red ball or a blue ball. I hope that is clear. Now, considering independent events, after we have considered what we meant by mutual exclusive, now we must also look out for what we mean by independent event. The word independent simply means that
one does not affect the other.
The event of one does not affect the other. Now, what do we mean by this?
Let's start an example.
The death of someone in the family does not affect what is happening in the Asurok. If somebody died in the village, does not actually have any effect in the meeting that is held in Asurok. That is, what we are saying here is that if anything is happening which does not actually directly and indirectly affect, directly or indirectly affect the events going on
in another particular place, then we say the event is independent of one another.
Now, looking at this, you say, what is the probability that the crisis in Nigeria affect the winning of 2012 Nations Cup? Now, if you look at it, the crisis in Nigeria is on its own.
The football nation is on its own, and to be fair, Nigeria
did not qualify for the Nations Cup. That means that the crisis in Nigeria does not have anything to do with the completion and the continuation and the winning of the Nations Cup. So therefore, you find out that the probability are what? These events are independent
of each other.
Now let's go to academics and find a simple example that has to do with our findings. So we'll pick this example in a basket of fruits. There are 2 oranges, 3 mangoes, and 3 pineapple. What is the probability that 1 orange and 1 mango will be picked? Now, when we are considering independent events, we should know that A and B are on their own. They do not affect each other. They do not depend on one another. And the symbol of that is what? Is both and what? Both. And what? Both. So when we see and both in a question, we should note that they are referring to what? Independent event. And how do we do that? We will just multiply because they are independent of
the Now looking at this,
total outcome will be what? Will be 2 oranges, 3 mangoes, 3 pineapple. So making a total of how many fruits do we have? We have how many? We have 8 fruits. So we have total outcome to be what? To be 8. Now, what are the probability of picking 1 orange? So it is what? It is 2 out of 8. The probability of picking another 1 mango, it is what? 3 out of 8. So we multiply it because we are dealing with what? A hand. So look at this hand, shows that is what? Is independent of each other. Then that means we have what? 6 out of what? Out of 64. So you can simplify this by dividing by 2. So 2 here, 3. 2 here is what? 32. So we have what? 33 over 32. That is the probability of picking 1 orange and 1 mango. I hope that is clear. Now, let's consider some example which I'm going to dictate and then you will see it on the screen. A bag contains 10 balls.
That differs only in color. 4 are blue and 6 are 2 balls are picked, one after the other, with replacements. What is the probability that both are red? What is the probability that both are red? And another question is, what is the probability that both are of the same color?
The first one is, what is the probability that both are red? And the second question is, what is the probability that both are of the same color? Now, to consider that, we said we have how many balls? We have 10 balls in a bag. And then we said we have 4 of them to be blue. 4 of them to be blue. That means 6 of them are what? Are red. So that means, this is what is the probability that both are red? Now, the probability that I will pick from the first bowl. Now, look at that question. It said with replacement. That is very important for you to take note. With replacement. That means that as I pick the first ball from the bowl, what did I do? I put it back. I pull out the first ball. Before I pick the second one, I put the first one back. Now, one thing we must practically understand now what is the probability that I will pick a red ball for the first time? The probability that I will pick a ball, because it is 6 out of 10, the probability that I will pick a red ball is what? 6 out of 10. And I said, with replacement. That means, before I want to take the second ball now, but before I take it, I have to return the red ball that is with me. So I return the red ball. So returning the red ball, that means that I want to pick the second ball. Now, if you notice, the ball in the basket now has complete 10 back because I have returned. So what is the probability of picking a red ball again? It is also what? 6 out of 10. The probability of picking the first ball the first time is 6 out of 10. Because I returned it, it is still 10 back. If I want to pick again, it is also 6 out of 10. So that means that it is this. And you remember that I said earlier that when you use both, when you hear hand in a sentence, what that simply means is that you should multiply. Now, in a probability question, when you hear both or hand, what that means is that you should what? Multiply. So what do you do, which is what? 36. 10 times 10, which is what? 100. So you can now divide to simplify the value, which will be what? So what can go in these two? 2 can go here, so it will be what? It will be 18. 2 here, 50. 2 here, 9. 2 here, 25. So we are going to have what? 9 out of what? 25. So the value, the probability of picking the first ball and the second ball to be red is what? 9 out of 25. Now, the second question is that what is the probability that both are the same color? Now, that means I have to solve for red and I have to solve for what? Blue. To say both are. If I pick the first one to be red, that means the probability of picking the second one to be red with replacement is what? Red, red. The probability of picking the first one to be blue and the probability of picking the second one to be blue, it is also what? Blue. And to do that, what we are going to do that is that, and you should note that if I have picked red first, that means the second one that I have to pick must also be what? Red. And if I have picked first, second pick must also be what? That means that red and exclusive. If I have picked red for the first time, if I have to pick red again, red because I picked red the first time, and blue the first time, that means that picking red or picking blue are mutually exclusive. So if they are mutually exclusive, what that means is that you have to add those two together. So let's see how it goes. The probability of picking the first ball, red, is what? 6 out of 10, just like what we did here. The probability of, it is with replacement. That means if I pick it, I return. So the probability of picking the second red, the probability of picking the red second is also what? Is also 6 out of 10. So what do I do? Because they are both and, the probability of picking this and this is what? 6 over 10 times 6 over what? 10. So which is going to be what? Which is going to be 36 over 100. Since we are picking the first color to be red, we are picking the second color to be what? We must pick the second color to be what? To be red. Now, let's assume that we pick the first ball to be blue. So that means that the first ball will be what? Will be blue, which is what? 4 out of 10. Now, if I had picked blue for the first time, and I will return it, that means with this replacement, I must also pick blue, because I'm talking of the same color now. I must also pick blue for the second time, and it must be what? Blue. So the second ball must also be what? Must also be blue. So it is probability of picking another blue color with replacements is what? 4 out of 10. So going about the way we did this, so it's going to be 4 over 10 times 4 over 10, which is what? 16 over 100. Because 4 times 4 is 16, and 10 times 10 is what? 100. So, because we are now saying that if I pick red first, I cannot pick blue second. If I pick blue first, I cannot pick red second, because they must be the same color. That means they are mutually exclusive. And when it is mutually exclusive, that means it must be what? It must be added. Therefore, it will be what? 36 over 100 plus 16 over 100, which is going to be what? All over 100 as the LCM, 36 plus 16. So when we add this together, we will get what? We will get 100. So if you divide, you will either get 0.52 as your what? As your value. So the probability of picking both to be the same color is 0.52 as a value. Considering this question, wants to know when we have 9 identical balls in a bag and 3 of them are black, 2 are blue, and the remaining, how many are the remaining? If 5 out of the ball has been known, that means the remaining 4 are red, right? So if a ball is drawn at random, what is the probability that it is not blue? Now, what is the probability that it is not what? Red. Now, earlier we discussed a question that is similar to this. I said then that for you to do this, you must identify your blue. Then you will now say it is not blue. It's going to be less by 1, because 1 is the maximum number you can get in the probability. So that means that to get blue, we now have what? We have the probability of being blue is what? Is 2 out of, because blue colors are what? Blue are 2. Let me make it this. It's a blue, black are what? Are 3. Blue are what? Are 2. Then red are what? Are the remaining, which is what? 4. Because the total is what? Is 9. The total is 9. So that means that 2 out of, for blue, that means 2 out of 9 is for our blue color. Now, for not blue, that means is of blue. Since it is not blue, I said we will less it by 1, and then we will less it from 1, then we'll get our not blue. So therefore, not blue equals to what? 1 minus 2 out of what? Out of 9. So that will give us what? That gives us, because I told you earlier that you have the power to change this 1 to any number, so far as it tallies with what? The denominator here. So we can have 9 over 9, because 9 over 9 is what? The same thing as what? As 1. So if you divide 9 by 9, you will get 1. So we have 2 over 9, which is equals to 9 as a LCM. Then it will now be 9 minus 2, which we have what? Which we have 7 over 9. So the probability that it is not a blue, it is what? 7 out of 9. The probability that it is blue, it is what? 2 out of 9. So also for the red, you know that the probability for red is what? 4 the value, the number of red that we have is what? 4. That means probability of getting red is 4 out of what? Out of 9. So the probability of being red is what? 4 out of 9. But the question does not say the probability of being red. The question says that the probability that is not red. So that means it's a negation to what? To red. So that means it's going to be not red. We therefore equals to 1 minus 4 out of what? Out of 9. So which is the same thing as what? 9 over 9, which is for this one, minus what? 4 over 9, which is equals to the LCM, which is 9 minus 4. And if you minus that, you are expected to get what? 5 over what? 9. So the probability of not being red is what? 5 out of 9. I hope that is clear. So the next question that we have here is what? If two balls are drawn at random, one after the other, what is the probability that both of them will be black if there is no replacement? Now, if you check the question we did before now, we found out that I emphasized on the word with replacement. But now we are emphasizing on what? No replacement.
What that simply means is that if I take it out, I am not returning it back into the bowl again. So that is the meaning of no replacement. If I'm taking it out, I'm not returning it. So we should be able to differentiate between no replacement and with replacement. With replacement is as I take it, before I take the other one, I have to return the one I have taken. So that one is what? With replacement. So let's see how this one goes with that.
Now, with replacement, what we have here is what? We have how many balls? 2 balls are drawn one after the other, and then which are from which ball? We are still referring to this particular question. So how many balls we have in total? We have 9
in total. And I want to pick out how many balls? 2 balls. And it's what? Out of replacement. So let's pick the first one and see how it goes. The probability of picking black for the first time is what? The probability of picking black is what? Is
3 out of 9.
So the probability of picking black is 3 out of 9. The probability of picking black is 3 out of 9. Now, let's assume I'm picking a black ball and it is black. And I'm picking a ball and it is black. How many balls and I'm not replacing it? How many balls is
remaining in my basket? It will surely remain what?
8. So the total ball I'm now having is what? 8 because it is without replacement. The total ball I'll be having now will be what? 8. Now how many black balls
will I still be having? If I've taken one already, I'll be having what? I'll be having just 2 balls remaining. So that means the black ball will remain what? The black ball. So what I will now have is now black is what? 2. Blue is still what? 2. Red is what? 4. And my total ball is now what? Is now 8.
Because I am picking a ball and I did not what? Replace. Now, what is the probability that I will now pick the second ball and the second ball will still what? Be black? Because the question says what is the probability of both become black? So the probability that I will pick the second ball and it will be what? Black. It is 2 out of 8, not
longer 3 out of 10 because my ball has reduced to 2 and 8 in total. So that means I'm going to have what? The probability of picking another ball and it is black, it is what? It is 2 out of 8. I hope that is clear. So picking 2 out of 8 is because I have picked one before and I did not replace it as the question says. That means I'm having my black ball less by 1 and I'm having my total ball less by 1. So that means I'm having 2 and 8 respectively for black and total balls. So that means the probability of picking my second ball to be red, my second ball to be black, I beg your pardon, will be what? 2 out of 8. So that means we have 2 out of 8. Now the question now says both. Now if you remember when I was talking about independent, then I mentioned that the occurrence of 1 does not affect the occurrence of 2. And I now describe that you can only relate that mathematically by A in conjunction with what? B. That is, placing them at the right each other. And when I told you then earlier, I said that if we are having A and B together, what that simply means is that you are multiplying. Definitely we are now saying 3 over 9 times 2 over 8. So 3 here, 1, 3 here, 3, 2 here, 1, 2 here, 4. So if I multiply 1 times 1, 1, this here, 2. So the probability of picking both to be black without replacements is what? 1 out of 12. Now, looking at the second question, we have blue. The probability of picking both to be blue if there is a replacement. Now, unlike the other one without replacement, if I pick a ball now, before I pick the other one, I must return the first ball. So, in other words, picking my first ball to be blue is what? 2 out of 9. Then I'll pick the ball. The probability of picking the ball is what? 2 out of 9. Now, before I pick the second one, because I have what? Replaced it. So my ball still remain 9. So the and my blue ball still remain 2. So the probability of picking another ball to be also blue, it is also what? 2 out of 9. Because my ball is complete back to the way it was before. So it is what? 2 out of 9. Therefore, the probability of picking both, the word both shows, just like I explained earlier, shows that what? It is a independent event is what? 2 over 9 times 2 over 9, which is going to be what? 4 over 81. So that is our what? Our value for the probability of picking the two to be blue with replacements. I said earlier that it must, when you are replacing, the value of your total outcome do not change. But when you are not replacing, the number of ball you pick for the first one, the number of objects you pick for the first time will be less from your total outcome. Now we look at another question under probability. Now look at this question. We say, in a fair die is rolled once and 2 unbiased coins are also tossed, what is the probability that of obtaining 3 and a tail? Now looking at this question, we have a die, just one die. Now the die has how many sides? It has total output for a die is what? Of a die is 6, because it has just 6 sides, and the 6 side contains of what? Contains of 1, 2, 3, 4, 5, and 6. So these are the sides that this particular die has. Now, we now have how many coins? We have 2 unbiased coins. That means, and you should notice, if you notice a coin, if you've seen a coins before, we find out that it has a head and a tail. Those are the 2 sides that a coin has. So let's say probability of a coin is what? Is 2. You know, the total probability of a coin. Now we are talking about how many coins? We're talking about 2 coins. So we are having what? 2 of 2, which is what? 4. We're having 2 sides. That means 2 sides. That means we're going to have 2 heads and 2 tails, because we're having 2 coins. So we say one head has 1 head and a tail, and then that means if you have 2, that means there will be 2 heads and 2 tails. So that means we are going to have, what we're going to have inside this one is going to be, we can have head, we can have head tail, we can also have tail head, and we can also have tail. What this simply means is that if the first die is head, the second die can also be head. If the first die is head, the second die may be tail. If the first die is tail, the first die may be head, and the 2 of them can be what? Can be tails, as it's shown. Now from here, now we are now asked a question that what is the probability of obtaining 3 from a die and a tail from a coin? What that means is that, you know, here we have no tail. If you look at this very well, here we have 1 tail, here we have 1 tail, here we have 2 tails. So the question is now directing that what's the probability of obtaining a tail, just 1 tail? So that means if you look at this, we can only find a tail here and a tail here. Only 1 tail can be got here. Only 1 tail can also be got here. So that means the probability of getting a tail is what? 2 out of 4, because there are 2. And another question here is now say, what's the probability of getting a 3 side of the die? Now the probability is just how many times can we have 3 shown on a die? It's just once, because these are the side of the die. So we only have, that means that 3 can only occur once in a die. So that means we have the probability of seeing 3 on a die is what? 1 out of 6. 1 out of the 6 side. And the probability of seeing a tail out of the 2 coin is what? Just 2 out of what? 4. Now, the question now emphasizes here that of seeing 3 and a tail. You remember what I discussed on and, which simply shows that they are independent of each other. Whatever comes out from die does not have anything to do with what comes out from coin. So therefore, we are going to what? Multiply. So multiplication, so what do we have? We are going to have what? We can divide if you want, say 2 here 1, 2 here 2. So we're going to have what? 1 over 1 out of what? 12. So the probability of getting 3 from a die and probability of getting
a tail from a coin is what?
1 out of 12. Now, let's consider another example. The radio repair shop has 10 small radios sitting on a shelf. 4 of these radios are defect, not visible to casual observers. A thief breaks into the shop and carries off half of these radios on the shelf. Now, we are looking for the probability that all the 5 radios stolen are good ones. Another one is 3 out of the 5 radios stolen are defective. And the last one, at least 1 out of the 5 radios are good. So, considering these questions, now if you look at this question critically, you find out that the radios stolen are what? Are picked without replacement. That there is no replacement after picking of each of those items. So let's consider solutions to this. Now, to see this, now first thing we have to look at how many radios are in the shelves. So we found out that the total outcome is what? Is 10. So the stolen ones are what? 5. So we are going to be picking each of the 5, one after the others, without replacement. So we now said, if you notice here, it said 4 of these radios are defects. So that means that if number of defects is what? 4. Number of good one. That means if 4 is bad, then the number of the good ones are what? Are 6. So if this is so, then I say what is the probability that all radio stolen are what? Are good ones. So considering that, that means that we have to find that each of the radio stolen or picked are picked without what? Replacement. And as they are being picked, then the total volume is reducing. The total of either defect or good ones are also what? Reducing. So let's consider this. So the first radio, first one, so of good one, so first one of good one, so it will be what? The probability of picking it is what? 6 out of 10. The probability of picking the second one, which is also a good one, is also what? 5 out of 9. Because I have picked 1, then it will remain what? It will remain 5. The probability of picking the first one to be good one is what? 6 out of 10. And immediately I pick a good one, a thief stole a good one. That means the number of good ones will reduce to 5. And then that means the total in the shelf will remain what? Will now reduce to 9. So if the probability of picking the third one is what? 4 out of 8. Because as soon as he picked 1, then it has reduced to 4. And the total in the shelf will now be what? 8. The probability of picking the fourth one is what? Which is also a good one, will be what? Will be 3 out of 7. Now, picking that as is where, so the probability of picking the fifth one, because how many was stolen? It said half of it was stolen. So the probability of picking the fifth one is what? Is 2 out of 6. I hope you can see that. It is what? 2 out of 6. So if it is 2 out of 6, then the next thing we need to consider is what? We now need to match this particular value. And if you notice that as you are picking it, it is without what? Replacement. Because if one is stolen, it is not placed back before the other one is being stolen. So how do we gather this together? Then we can gather it up with what? Because if you notice, they are depending on it, they are mutual exclusive. So in this other word, then it will now be what? 6 over 10 plus 5 over 9 plus 4 over 8 plus 3 over 7 plus 2 over what? Over 6. So the total probability of picking a good one is this. So the next thing we need to do is what? To find the LCM. Now, how do we find the LCM of this? We look for the number that can actually divide everything. So let's consider which number can we do. So let's just find the LCM and see how we'll be able to go about this. 2 can go, this is 5, 9, without, it can't go, 2 cannot go without remaining 4, 2 cannot go without remaining 3. The next value that can go, 2 can still go. So we have 5, 9, 2, 7, 3. 2 can still move. We have 5, we have 9, we have 1, we have 7, we have 3. So 3 can go now. We have 3, we have 5, we have 3, we have 1, we have 7, we have 1. 3 can still go. 5, 5, we have 1, 1, 7, 1. So we have 5, we have 1, 1, 1, and we have 7. So now we can 7 can go 1, 1, 1, 7, 1, and 1. So if you find out that these are the values that we have that we can use as an LCM, so we now say 2 times 2, 4, 8, 24. 24 times 2, that will give us what? That will 24 times 3, that will give us 72. Okay, 72 times 5, that will give us 136. 136. So times 7 will give us 0. This times this, 7 times that was 42. That was 2. 4, 7 times 21. 21 plus 4, that will be 25. So we have 1,225 as our LCM.
Now, what we have here is a radio. We have a set of 10 small radios in a shell, and out of the 10 radio, 5 is being stolen. Now, we're now looking for the probability that all the 5 stolen are good ones. Now, we're now going to look at it that if the 5 stolen ones are good ones, and then you should note that when a particular radio is being picked from the shell, it is not being returned. It is being picked without a replacement. So if the first one is being picked and the second one is being picked, and that means that as they are being picked, the volumes of the radio on the shelf reduces. So let's now talk about how the material are being reduced. The total outcome of the radio is what? The total number of the radio is 10. The bad ones, according to the question, is 4. That means the number of good ones are what? Are just 6. Now, the probability of picking the first one to be good one, it is what? 6 out of 10. If that one is being taken, the probability of taking the second one, which is expected to be good, is now what? 5 out of 9. The probability of taking the third one is now what? 4 out of 8, because you are taking them without being replaced. The probability of taking the fourth one is 3 out of 7. And the probability of taking the fifth one is what? 2 out of 6, because they are being picked without being replaced. Now, we now have what? We have, when the last one is the probability of picking the fifth one to be what? To be good one is 2 out of 6. Now, we now have this. We now have, because the picking are independent of each other, so we're going to make this a value of independence. So that's why we are having 6 over 10 multiplied by 5 over 9 multiplied by 4 over 8 multiplied by 3 over 7, because if you are pick one, it doesn't affect the other one being picked. Therefore, they are independent they are independent events. So if you are now multiplying 6, if you multiply 6 by 5, by 4, by 3, by 2, you expect to get 720. And 10 times 9 times 8 times 7 times 6, you are expected to get 30,240. So if you divide this by this, you are going to get this. So the probability of stealing the 5 out of the whole thing on the shelf is what? 0.024 as a whole. I hope that is clear. Then the next question was now saying 3 out of the 5 are defects. What that means is that when you pick, you only pick 3 that are bad. The remaining 2 are good. So that is the meaning. So that means that we only pick 3 bad ones, 2 good ones. So we're going to change this analysis. Now, considering the fact of having 3 out of the 5 to be defective. Now that means that the probability that the first one picked, let's say the first one picked is bad one. So the probability of picking a bad one is what? For the first time, the probability of picking a bad one is what? 4 out of 10. And immediately has picked the bad one, number 1. So if you want to pick it again, that means that let's assume that he's still picking a bad one for the second time, because they say he's picking bad one 3 times out of the 5 times. So probability of picking a bad one for the second time is going to be what? 3 out of 9. The reason is that the number of bad ones are reducing because it is without replacement. When a thief carries something and he wants to carry another one, it's not replacing the former one that he actually dropped. So it is what? 3 out of 9. So the probability of picking another bad one for the 3rd time is going to be what? It's going to be 2 out of what? Out of 8, because the value is reducing. Now the probability, now we said picking what? 3 out of the 5 to be what? To be defective. Now the probability of picking the 4th one. The 4th one now is not going to be a bad one, it's going to be a good one, because he has already picked 3 out of the bad for the bad one. So the probability of picking a good one is now going to be what? It's going to be 6 out of what? 6 out of 7. Because the total is keep on reducing, but so far he has not touched any good one. But the good ones still remain number 6. Now the probability of picking the 5th one to be a good one is now going to be what? It's going to be 5 out of 6. I hope it is clear. I repeat. Now he's picking the bad one for the first time, and the total of it is what? 10. So that's why we are having what? 3 out of 10. He's picking the bad one again, and the number of bad one reduced to 3, and the total also reduced to 9. He's picking another bad one again, the bad one remains what? 2, and the total remains what? 8. Now he's picking a good one. Now the good one, probably not picking a good one is 6 out of the remaining, which is what? 7. He's picking another good one, is now remaining, this one will drop to 5. Out of what? Out of the remaining good one, out of the total radio of what? Of 6. Now, to now find the probability of considering 3 out of 5, it will now be what? 4 over 10 times 3 over 9 times 2 over 8 times 6 over 7 times 5 over 6. So let's do the multiplication and let's see. 4 times 3, 12 times 2, 24. 6 times 5, 30, 24 times 30. That will give us what? 24 times 30. That will give us 720. I guess that is what we get. So 720, and then we now have to multiply all this one. 10 times 9 times 8 times 7 times 6. That will give us, so what do we get? We get 3240. So that means that if you divide this, the probability of getting these is what? What do we have as the value? So that is what? 0.024. That is the probability of 3 out of 5 hours are defective. Now, considering the last question, we said at least 2 out of 5 are good. Now, what this simply means is that out of the 5, the minimum that are good that we can see is what? 2. Now, it's saying that what this simply expression is saying that at least the probability that there is 2 of them is good, or the 2 of them, more than 3 can be good, and 4 can also be good out of them, and the whole 5 can be good. But it cannot be less than 2 out of the whole thing that are what? That are good. That all of them, that more than 2 or 2 are good out of the whole 5 that is being studied. That means that the whole 5 is good, 4 out of the whole 5 will be good, 3 of the whole 5 will be good, or 2 of the whole 5 is good. But what this simply means is that if 5 of the whole 5 is good, that means 2 out of them cannot be good. That simply means that the result of one is depend on the what and the other. We cannot have 2 being good and as well as 3 being good and as well as 4 being good. So that means that at least only one of them will be good. Either 2 of them is good at the time, or 3 of them is being good at the time, or 2 of them being good. But what we are saying in this question in essence is that at least the list there is saying that the minimum good that we can find in that particular stolen goods must be 2 out of 5. So let's see how it goes. So what we're going to do is that we're going to look for the probability that 2 of them are good. We look for the probability that 3 of them are good. We look at the probability for 4 of them are good. We look for the probability of 5 of them are what? Are good. So let's consider that. Now, say the first one, the second one, third one, fourth one, and the fifth one. So for probability of the first one being good, and you remember that we said that 4 is bad out of what? Out of 10. That is the question. It said that out of the 10 radios, 4 are bad. So that means that the probability of picking 2 good out of the whole thing is that we have 6 out of 10, 5 out of 9. That is the 2 out of the whole. So the minimum ones are what? The minimum ones are bad. So that means it's going to be 4 out of 8. It's going to be 3 out of 7 and what? And 2 out of 6. At least 3 are what? Are good will be what? 6 out of 10, 5 out of 9. It will be reducing just like we have explained in the first 2 questions, which will be what? For the third one, which will be what? 4 out of 8. Then the bad ones now, after considering the 3 good ones, the bad one will now be what? Will be 4 out of 7 and 3 out of 6. Now, at least 4 of them are good. Will be 6 out of 10, 5 out of 9, 4 out of 8, 3 out of 7, and then the last one, these are 4. The last one will be a bad one, which is what? 4 out of 6. Now let's consider when all of them are good. Then it will be what? 6 out of 10, 5 out of 9, 4 out of 8, 3 out of 7, and 2 out of 6. Now let's consider these. Let's multiply this and let's multiply this. Let's multiply this. Let's multiply this so that we can have the probability of 2 good ones, the probability of 3 good ones, the probability of 4 good ones, and the probability of 5 good ones out of the whole 5. Okay, after we have actually written all our probability of being 2, being 3, being 4, being 5 out, then the next thing is now to multiply just like we've done before. 6 over 10 times 5 over 9 times 4 over 8 times 3 over 7 times 2 over 6. Better still, you can say 6 times 5 times 4 times 3 times 2. That will give us 720. Then 10 times 9 times 8 times 7 times 6. That will give us what? 30,240. Then the next one is the same thing as 6 times 5 times 4 times 4 times 3, which is the same thing as this 6 over 10 plus 5 over 9 plus 4 over 8 plus 4 over 7 That's times 4 over times 3 over what? That's 3 over 6. 6 over 10 times 5 over 9 times 4 over 8 times 4 over 7 times 3 over 8. So that will give us what? 1,440, and then all over, if you multiply over what? 30,240. So if you also do the same thing here, you will find out that we get 1,440 and over 30,240. And the last one here, you can do the multiplication, you find out that we have 720. That is 5 times 6 times 4 times 3 times 2. And 10 times 9 times 8 times 7 times 6 is what? 30,240. So if you add them together, you find out that we now find the LCM of all of them. You see we have this plus 1440 plus 1440 plus 720. So addition of this one will give us what? 4,320 all over what? 30,240. So define this one, you divide it, and then you are very sure you will get 0.143. What that is the probability that at least to the probability that at least that's greater than equals to 2 out of 5 is what? Is 0.143. I hope that is clear.